Okay, here we are going live. We're gonna give ourselves a little minute to get some people here. It takes a minute, so let them all know. Beck will tell us if things start popping. All right, this is very exciting. Sean, I'm about to introduce you, but I don't know your last name.
O'Brien.
Sean O'Brien and Ron Nykirk from Agilent Vacuum are in the house, and we've solicited some questions from our friends on Instagram, and we are prepared to answer them.
Okay, so we're going to start off, and the first question was, which machine do you recommend for a 15-hour continuous workday?
Well, I mean, a 15-hour continuous workday on a berry farm, I recommend a berry picker. So there's not enough information in that question for us to answer it. But all of Agilent's vacuum pumps.
All pumps are designed to run continuously for sometimes in years. So depending on the application, what it is you're pumping, if it's a purge oven for BHO, or what it is we're doing, that determines on whether or not we want to have a duty cycle that is less than 24 hours, if you can run continuously. It really is, the devil's in the details. We need to know about the application.
So every pump that Cascade sells is able to run 24/7. I can't think of a vacuum pump that we sell that can't run 24/7. Now, that's 24/7 within the specified range. In other words, an oil pump doesn't want to run open to the atmosphere. It wants to run against a closed door, whether that be deadheaded on a gauge or a closed door on a vacuum oven. It wants to achieve a vacuum and maintain it. All of our pumps can do that all stinking day long, weeks at a time. But if you're going to be introducing chemistries, introducing a lot of moisture content, having a very large vapor load, trying to pull a vacuum on this room with an IDP 15, that's going to be a sad pump. Right?
Pumps have a continuous maximum inlet pressure. So if you don't get a pump down to below that pressure, it's going to heat the pump up and you'll probably end up tripping out for over temp.
Now, when we say tripping out, this is something entirely different than what you're thinking right now. Let me rephrase. What could happen is that the motor could overheat and there's an internal fuse that...
There's an internal temperature switch that will open up and stop the pump to keep it from overheating and destroying itself.
And then you're welcome to go trip out anytime you like.
While the pump's off?
Or on.
It's much safer to trip out while the pump's off.
Correct. So the answer is, can you run what would be best for a 15-hour day? Any of our pumps, as long as it's the right pump for that application.
Great, well thanks for those answers. We're going to go down to the next question. When pulling initial vacuum on fresh hydrocarbon extract, do you open the ballast valve for a bit?
I mean, I have what I think of as the right answer, and so does Ron, and so I want Ron to go first.
Gas ballast is a tool that we use to pump condensable vapors. Essentially what we're doing is introducing a little bit of atmospheric pressure air into the final compression stage of the pump. This adds heat by compressing that additional air, heating up the pump and allowing condensable vapors to go through the pump without condensing. You don't want water vapor becoming water inside the pump. So in this case, in a BHO purge oven, you don't have condensable vapors. There really is no reason to use a gas ballast.
Here's what I think about that. Ron is correct, and Ron is coming this from the point of view of how do I protect and maintain the integrity of the pump, and in this case, we're talking about the scroll pump series, the IDP 3, 7, 15 that goes standard on our vacuum ovens. Because the gas ballast valve in that application is letting in a little extra air in the final stage of the pump, it is also going to have the side effect of mitigating the vacuum level. It's not going to drop to quite such a deep level, which in BHO applications I think is excellent. In fact, I am a proponent of using a backfill gas during the initial stages of the purge process so that you can mitigate that powerful vacuum pump a little bit by adding a backfill gas so that you don't do a lot of muffining.
And the backfill gas needs to be controlled. because otherwise you're just going to have a pressure that's going to
Correct.
fluctuate around.
Correct.
So a common practice is to use what's called a mass flow controller to vary the amount of gas that is doing the control of the pressure, and then it uses the feedback from the gauge to control different levels of the gas flow.
Okay, and Aiden's holding up a sign, and he wants me to tell you all. Can I read it? You put down your sign. We have a new video for the DS302 ballast, spelled incorrectly, coming soon on our YouTube channel. So there's a new video about the DS302, and the DS302 is not a scroll pump, that's going to be an oil pump, but again, gas ballast can be useful in that application as well.
Gas ballast works the same for all pumps. It just uses the additional amount of gas being compressed, the heat generated from that compression to increase the heat of the pump to allow condensable vapors to go through as vapors and not liquids.
Excellent.
Great.
Any more questions?
We do. We have a third question. Are there any SOPs for vac purging pentane?
Well, I'm sure that there are a million, but you're not just vac purging pentane. You're probably trying to create something. I suspect that we're making some kind of diamonds or doing some kind of crystallization with a co-solvent, I suspect. So I would want to find out exactly what we're doing with the pentane, and then we can certainly assist you with putting together an SOP for that. But what I don't want to see is anyone using a vacuum oven as a pressure chamber. So what I don't want is just because you need a warm place at 80 degrees to put your jars because you're making crystals, and the only box that you have that makes temperature is a vacuum oven, you're going to use that. I mean, I get that there was a time when everybody had a lab in their garage and we would like take vacuum pumps off of one thing and put it on something else, and can I use the vacuum pump for my roto on my thing? You know, yes, you can, but your results will vary. If you're serious about your business, what you want when you're working on crystals is you really want a crystal reactor. That's the kind of thing that we can sell you. If you want to work with pentane in your vac oven, give me a call, we'll figure it out.
Would you introduce the gentleman in the red shirt?
Oh, the gentleman in the red shirt.
My name is Ron Nykirk. I'm with Agilent Vacuum Products, and I work with Cascade Sciences to provide the best vacuum equipment that you can possibly use in your process.
I met Ron Nykirk in
Probably 2009, 2008.
Before that, I think at Sheldon. Weren't you calling him Sheldon?
That's true.
Yeah.
Before that.
I met Ron Nykirk probably closer between 2005 and 2007, somewhere in there. Ron has been selling high-end vacuum processing equipment for a number of different manufacturers for really, well, I mean, longer than Sean's been alive.
About 35 years.
Longer than Sean's been alive. So, I mean, and Sean's super smart, so you could see how much experience Ron has. But what Agilent has done to support Cascade in this industry has been so fantastic. Because before there was any adult use legislation, before it seemed safe to go in the water for most companies, Agilent was willing to partner with then Cascade Botanical to service this market, and has been integral. Ron personally, I'm sure that we have customers giving Ron props on there right now because he has visited them, he has called them, he has gotten emails from them. So huge shout out to Ron Nykirk because
Lots of hearts.
Lots of hearts for Ron, and they're all absolutely coming for me as well, because whether my customer is Fat Dog Farms in Grants Pass or Blue Origin in Washington or somewhere in the Gorge or somewhere in Florida, today we've been on the phone with everybody from surgical suture manufacturers to folks crashing out crystals, and Ron is my go-to guy for all those questions in all of our applications. Any other questions?
See, does anyone out there have any questions right now? Basically, I'm just hearing what's been delivered from you recently.
Uh-oh.
Yeah, LED one shot had a Cascade decarb oven and their lab armor bead bath delivered yesterday.
Oh, LED one-shot man. He's in Ohio now. I think it's Ohio, but he was in Massachusetts when he started buying stuff. I met him on Reddit.
Yeah, looks like they're loving their stuff.
Of course. He's rolling Cascade old school swag. Okay, I have a question for Ron. I have a question for Sean. Let's put Sean on the hot spot.
Sure.
Okay, Sean, I have an IDP7, but I'm in Denver, Colorado. Is it going to pull a full vac?
Yes. So your base pressure is going to be the same depending on what altitude you're at. What pressure you're starting at is going to change. Since the pressure is going to be a little bit lower already, you're going to have just a shorter distance to reach ultimate vacuum.
So a lot of vacuum ovens in cannabis early on were not digital, they were analog gauge. So it was super confusing to folks about whether or not they were reaching their full vacuum. But all the vacuum pumps that we sell can reach their absolute spec, even if the gauge doesn't know it, right?
Sure. So your gauge is starting at what it thinks the room is. So if your room's a little bit lower in Denver or atmospheric's lower, it might be a little bit confusing, but that ultimate pressure is always going to be the same.
Exactly. What's another hard question for Sean? Got a good one?
I don't think.
There's no hard question for Sean? No, there's no hard question for Sean. Okay, I've got one. So in the short path application, and this is not like the pure path short path, but this would be benchtop short path, they go through pumps and the oil every couple of days. They want 10 millitorr and not to have the pump degraded. How do we help them achieve that?
The best practices are to make sure that your cold trap is constantly cold, is constantly being serviced. So if you're using dry ice and ethanol or some other fluid to transfer that cold power from the ice to glass, make sure you are always keeping that level up. Make sure you are always having the dry ice charged, because as soon as you no longer have the cold trap cold, everything's coming from that distillation process. All that gas is going straight into the pump. The purpose of the cold trap is to protect that from going to the pump. That then contaminates your oil. It affects the way the pump is lubricated, and it also affects the base pressure, because we use special fluids in the pumps that have a low base pressure. And it has to be below the rated base pressure of the pump. If it's above that, then the vapor coming off of the oil is going to be the limiting factor of your base pressure of the pump. If you have alcohol coming from your process and going into the oil and the fluid of the pump, then the vapor pressure of the alcohol will limit you on the base pressure of your pump.
But tell me, is an oil pump the right pump for that application?
It depends on whether or not you are going to be able to trap everything out of it. The oil is going to get contaminated with any carryover past the trap. We usually like to use a dry pump that does not have oil, because then we can trap it both in the inlet and the exhaust. When you have an oil-based pump, the oil becomes a receptacle for all the contaminants that go in. And that corrupts the oil to the point where it no longer provides the ability to flow through the small passages to the bushings and the bearings. It doesn't provide the same lubrication for the sliding veins inside. And it's going to end up having to be changed on a very frequent basis. And if your maintenance cycle isn't maintained, you're going to end up destroying the pump.
Okay. Yeah, that's an interesting application that I'd love to find a good solution for. You got any questions over there?
You actually just ended up answering one.
Oh, I did?
Yeah.
Why
dry scroll over oil?
Oh, okay, yeah, dry scroll over oil, definitely. The other thing is I want, everybody remember back in the day when we were selling, everybody had an Edwards 30 on their Across 1.9 vacuum oven. You could walk into any one of those labs and just touch the surface, and that sticky icky was not cannabis. That sticky icky was all of the oil mist that was not properly exhausted from those oil pumps. So people call it exhaust smoke that's coming out of those oil pumps. It's not smoke, it's mist that's finely emulsified, and it's gonna collect on things and lay on your slabs, and they're ugly in the lab.
The other question about using oil is that oil will backstream.
Yeah.
When you are at the ultimate pressure of the pump, the inlet, there's enough room between the molecules for oil molecules to bounce back around and end up in your process.
Okay, and that's not, so there's two kinds of backstreaming that can happen in an oil pump. The first one is just user error. I've got a pump, I've got an oven, I close off the valve to the pump. It's the oven is under vacuum, my pump's turned off. If I opened up the valve and the pump was turned off, the oven's gonna equalize pressure and can suck that oil. Of course, we would always have a 4-line trap on there, but it could suck the oil back in a big gulp. The other way is cooler because physics, right? So there's viscous flow and molecular flow. So viscous flow is when there's enough molecules in the chamber that I'm actually sucking them out, and it's actually vacuum like a vacuum cleaner. Viscous flow, right? Once it gets down to
About 100 millitorr.
100 millitorr, you no longer have enough molecules to actually suck them out. So those molecules are going to bounce around the way molecules do and find their way up the path. Is that kind of how you would say it? You say it in a better way.
And you could think of a super ball that's going to bounce around the room forever. You have to wait till that super ball bounces to the door to remove it. So that's in molecular flow. Once you don't have as many molecules bouncing around, those oil molecules can bounce and make their way back up into your process.
And so that's something you want to be aware of.
You can think of viscous flow as wind. It's a directionality of the flow of gas molecules. My analogy is Fifth Avenue in New York City during rush hour. If you're walking up the sidewalk going north and everybody else is going north, if you want to go south, you're not going to get very far. You'll be pushed north. You got to cross the street, go to the south side.
Yeah.
Now, at midnight, there are not going to be many people there. You can walk any direction you want. So viscous flow is when there's directionality that's pushing you in a direction. You have the momentum transfer of those molecules, pushing them all in the same direction. As the mean free path, the distance between the molecules, opens up as the pressure gets lower, then the molecules can go any which way they want. And as Sean pointed out, the ability of that molecule to hit another molecule and impart momentum to it and put it in a direction goes down with the pressure. So then that oil molecule that's bouncing around like a super ball can wend its way between the molecules and eventually find its way back upstream into your process and your product.
Interesting. Okay, I think that we're good. We've answered a bunch of questions. Thanks everybody for coming. Thank you, Sean and Ron from Agilent. Woo! Cascade signing out.